So here we are revising operations on single random variable. We are taking only one random variable. What are the different operations that can be performed on single random variable? The first operation that can perform on single random variable is expectation. Expectation is the name given to the process of averaging when a random variable is involved. Okay, so it is nothing but the averaging or mean. Okay, so when random variable is involved, then it is called expectation. How do we denote this? We denote it as E of x. Okay, so how do we call it? Is we call it as expectation of x or mean value of x. Okay, and statistical average of x. Like this, these are the different names we use to represent expectation. So expectation is nothing but mean or average or expected value of a random variable. Okay, how do we write it as? We write it as x bar is equal to E of x. This is the notation we use to represent expectation. Okay, and we will be discussing what is the expectation of a random variable. And we have discussed that there are two types of random variables. No, so for example, if you are taking x, capital X is a continuous random variable with a valid probability density function fx of x. Fx of x is the probability density function of x. Okay, then the expected value is given by the formula. You should remember this formula. The formula is given as expected value of x is equal to x bar some integral minus infinity to plus infinity x fx of x dx. Okay, so this is the formula we use to obtain the expected value of x if a continuous random variable x with the probability density function fx of x is involved. Okay, similarly in the case of discrete random variable, so if you take discrete random variable, what is that? A random variable will have the discrete elements x is equal to x1 x2 x3 so on xn. These are the elements of discrete random variable. Okay, and these elements will be having the probabilities. What are the probabilities? Given as p of x1, p of x2 so on p of xn are the probabilities of these discrete random variables. Okay, now in that case the expectation is given by the formula expected value of x is equal to summation n is equal to 1 to n xi p of xi. This is the formula we use to obtain the expectation of discrete random variable. Okay, so you should also remember this formula. Okay, and similarly, if a function is involved, for example, if these discrete random variables we have discussed, no, all these discrete elements have the same probability. That is, for example, when you throw a die. So if you throw a die, what are the possible outcomes? We are getting the outcomes as 1, 2, 3, 4, 5, 6. Okay, so these are the possible outcomes we are getting when we throw a die, and we know that the probability of getting each outcome. Okay, so that is probability of getting 1 is equal to probability of getting 2 so on like that. Yes or no? So it is equal to probability of getting 3, yes 6. Okay, so on like this. And what is the probability of getting outcome 1? The probability of getting outcome 1 is equal to 1 by 6. Okay, so in that case what is the expected value? Means that each outcome is having the same probability. So what is these elements are called equal probability elements. Okay, in that case the expected value can be written as summation I is equal to 1 to n xi divided by n. So that is equal to 1 by n x1 plus x2 plus x3 so on xn. So this is the formula we use to obtain the expected value of equiprobable elements. Okay, in the case of discrete. Okay, so now we'll discuss how do we apply the how do we obtain expected value of a function of a random variable. Okay, for example, we have a random variable x. Okay, and whose probability density function is fx of x. Okay, now we have to obtain what is the expected value of g, which is function of x. Means that we have to obtain g of x, expected value of g of x. Okay, to obtain g of x, what is the formula here? It is same as the formula whatever we have discussed for continuous random variable. Instead of x here we have g of x, that's all. Okay, so it is integral minus infinity to plus infinity g of x fx of x dx. Okay, so this is the case for continuous function. Whereas if you are considering the discrete function, Now see here, it is expected value of g of x. Here also it is expected value of g of x is equal to summation I is equal to 1 to n g of xi p of xi. This is the function we have to use. Okay, to obtain the expected value of discrete random variable, which is function of a random variable. Okay, now we'll discuss how the conditional expected value of a random variable can be obtained. Okay, so we have discussed that what is the expected value of a continuous random variable. It is given as e of x is equal to integral minus infinity to plus infinity x fx of x dx. Okay, so this is the expected value of continuous random variable. Okay, now what is that we are doing? We are taking the conditional density function. What is the conditional density function? Fx of x by y is the conditional density function. Now we find out what is the mean expected value of this conditional random variable. Expected value of the conditional expected value or expected value of conditional random variable. It is given as e of x by b is equal to, now here we have a condition. No, that condition is applied in the case of density function. So it is integral minus infinity to plus infinity x fx of x by b dx. Okay, so this is the formula to find out the expected conditional expected value of a random variable. Now what is B here is called conditioning event. This B is defined like this. B is equal to x less than or equal to B, where B value is varying from minus infinity less than B less than infinity. Similarly, fx of x given x less than or equal to b. From the conditional density function, we have discussed what is the formula for conditional density function. It can be defined for two cases. The first one is for x less than b, for x greater than or equal to b. So for x less than b, the conditional density function is given by fx of x divided by integral minus infinity to b fx of x dx. So this we have discussed when we have discussed about conditional density function. Conditional density function is defined for two cases. The first case is for x less than b. The second case is for x greater than or equal to b. For x less than b, conditional density function is given as fx of x divided by integral minus infinity to b fx of x dx. Okay. For x greater than or equal to b, what is its value will be 0. So this equation we will be substituting the equation of conditional expected value. Okay, so in the if you substitute that in the equation conditional expected value, so what we will be getting, expected value of x given x less than or equal to b will be equal to what? So it is integral minus infinity to b x fx of x dx divided by minus infinity to b fx of x dx. Okay, so this is the formula we get for finding conditional expected value of a random variable. Okay, so we'll do this problem. Find the expected value of uniform distribution random variable. So for this you should know what is the probability density function of uniform distribution random variable, because what is the formula of expected value of a random variable? The expected value of a random variable x is equal to, it is integral minus infinity to plus infinity x fx of x dx. Okay, x fx of x dx. Okay, so this is the formula. So what is that? You should know what is the probability density function of uniform random variable. So all of you should remember what are the probability density functions of different random variable, then only you can solve this type of problems. Okay, so the uniform random variable is having the probability density function. It is given as fx of x is equal to 1 by b minus a less than x less than b, 0 otherwise. Okay, so this is that you have to remember. This equation will not be given in the problem. Now, just now we have discussed what is the expected value of x. The expected value of x is given as integral x fx of x dx. Okay, so this is the formula for expected value of x. Okay, so expected value of x can be written as, you see here, if you see this condition, this 1 by b minus a is defined only for a less than x less than b. Only for this duration, what is fx of x? It is equal to 1 by b minus a. So for the integral a to b, What is that given? X by b minus a dx. Okay. So if you solve this, we get expected value of x is equal to b plus a by 2. Okay, now we'll discuss the properties of expectation. So the first property says that a random variable x, if random variable x is a constant, then expected value of a constant will be equal to the same value. Expected value of a will be equal to a only. Okay, and the second property says that if a is any constant, then expected value of a of x is equal to what? A into expected value of x. Okay, so this is our second property. The third property says that if a and b are any two constants, then expected value of ax plus b is equal to a expected value of x plus b. Okay, so this is the third property. And the fourth property says that if x is greater than or equal to 0, then expected value of x is also greater than or equal to 0. Okay, and the fifth property says that if x is any random variable, then mod expected value of x will be always less than or equal to expected value of mod x. Okay, mod expected value of x will be always less than or equal to expected value of mod x. That is our fifth property. And sixth property says that if g1 of x and g2 of x are two functions, okay, functions of a random variable x, then expected value of g1 of x plus g2 of x will be equal to expected value of g1 of x plus expected value of g2 of x. This is our third property, sixth property. Okay. So now we'll see this problem here. If x is a discrete random variable with the probability mass function given in the table, here it is given in the table. What are the elements of that random variable and what are the corresponding probabilities also given. Okay. Then find expected value of x, expected value of 2x plus 3, expected value of x square, expected value of 2x plus 1 whole square. This is that given. Okay. How do you find out expected value of x? It is summation n is equal to how many elements we have? 5 elements. N is equal to 1 to n xi p of xi. Okay. So summation n is equal to 1 to n p of xi p of xi. So how many elements we have? Totally 5 elements. Okay. Now what is that we have to do? Minus 2 into 1 by 5 plus minus 1 into 2 by 5 plus 0 into 1 by 5 plus 1 into 1 by 10 plus 2 into 1 by 5. Okay, these products. So I have to find out these products and add all these products to find the expected value. So the same thing we have done here. Minus 2 into 1 by 5 minus 1 into 2 by 5, 0 into 1 by 10. Okay, and then 1 into 1 by 10 plus 2 into 1 by 5. Okay, so you have to add all these product terms. That gives us what is that expected value of x. Okay, then from the property of expected value, we know that expected value of 2x plus 3 will be equal to 2 into expected value of x plus 3. 2 into expected value of x plus 3. So here we will be substituting expected value of x and we are finding what is the expected value of 2x plus 3. Similarly, we have to find out what is the expected value of x square. So x square is a function, no? So how do we write it as? We write it as g of x is equal to x square. Now expected value of g of x is equal to summation g of xi p of xi. Okay. What is g of xi here? X square. So it is xi square. Okay. So it is summation I is equal to 1 to 5 xi square p of xi. Okay, what we have to do here? We have to square all these x terms. We have to square all these x terms. Okay, and multiply the square with the corresponding probabilities. Okay, you will be getting product term now. So these product terms will be added for all the I values. Okay, so here we are not squaring here, whereas here it is given as x square. We have to square, that is minus 2 square into 1 by 5 minus 1 square into 2 by 5 plus 0 into 1 by 5. So 1 square into 1 by 10. Okay, plus 2 square into 1 by 5. Like that we have to do. That gives us expected value of x square. Okay. Similarly, to find out expected value of 2x plus 1 whole square, what you have to do, you have to expand this function now. Expand this function, 2x plus 1 whole square will be expanding. We get 4x square plus 4x plus 1. 4x square plus 4x plus 1. So now expected value of 4x square plus 4x plus 1 will be equal to what? 4 expected value of x square plus 4 expected value of x plus 1. Okay. So this we already found expected value of x square we have already found. Expected value of x also we have already found. We will be substituting those values and we are obtaining what is expected value of 2x plus 1 whole square is 8.2.
That's 7.5.
So now we'll discuss movements. Okay, there are two types of movements now. Movements about the origin and movements about the mean or central movement. Movements about the origin, movements about the mean. It is also called central movement. What is central movement? It is movement about the mean. Okay. Now we'll discuss what are the movements about the origin. Okay. Now what is that we are doing? We are taking a real function g of x. Okay. We are taking real function g of x and we this function g of x is equal to x power n. Okay. The expected value of g of x is called movement about the origin. Okay. So how do we denote? We denote it as mn. We use mn to represent the movement about the origin. What is n here? N is called order of the movement. Okay. N is called order of the movement. What is mn? Mn is expected value of x power n. Okay, because n we are taking no expected value of x power n. So what is the formula? Some integral minus infinity to plus infinity x power n fx of x dx. Okay, this is the formula. Okay. Now for the case of discrete random variable, instead of integral here, we will be having summation. Expected value of x power n is equal to summation xi power n p of xi. Okay. Then if n is equal to 0, so we are finding zeroth moment. Okay, what is n? N is called order of the moment. No? If n is equal to 0, then it is called zeroth moment. So what is m0? M0 will be integral minus infinity to plus infinity. Here you have x power n, no? X power n we have. This n will be 0. X power 0 fx of x dx. So since x power 0 is 1, so we know that from the properties of density function, the area under density function will be always equal to 1. So the zeroth moment will be always equal to 1. It gives us the area of PDF, probability density function. Similarly, if n is equal to 1, so that is the first order. If n is equal to 1, we get m1 is equal to integral minus infinity to plus infinity x fx of x dx. Okay, so you observe this formula. This is the formula of expected value of x. Okay, so from this we can say that the first moment will give us the mean value or expected value. So what is m1? The first moment will be equal to expected value of x, or it is also equal to the mean value, that is called x bar. Similarly, if n is equal to 2, so what is the formula? We call it as m2. It is equal to integral minus infinity to plus infinity x square fx of x dx. Okay. So we what is this called? It is called expected value of x square. Okay. So this is also called mean square value of x. Expected value of x square is called what? Mean square value of x. Okay. It is called mean square value of x. Okay. So, so what is the importance of mean square value of x? The mean square value of x will give us the average power of the signal. Okay. So, and the square root of mean square value gives us RMS value of the signal. Okay, so what is the importance of mean square value or M2? M2 gives us average power of the signal, and it is also gives us the square root of M2 gives us the RMS value of the signal. Okay, so that is why these are important. So what is a movement about the horizon? Movement about the horizon will be given by, this is the formula. Okay, and if n is equal to, n is called order of the movement. If n is equal to 0, the zeroth moment about the horizon will be having value 1. and first moment about the horizon will be giving the mean value or expected value, and the second moment gives us the average power of the random variable, and the square root of m2 gives us the RMS value of the power. Okay, and now we'll discuss what are the movements above the mean. So movements above the mean can be represented as g of x is equal to x minus x bar whole power n. G of x is equal to x minus x bar whole power n. The expected value of g of x is called movement above the mean of the random variable. So what is movement above the mean of the random variable? It is the expected value of the function g of x. What is g of x? G of x is equal to x minus x bar whole power n. So this is called mean of the random variable. Okay, it is a movement about the mean of the random variable. And how do we denote? We denote it as mu n. Okay, whereas in the previous case we call it as mn. Now this central movement we call it as mu n. Okay, and what is n? N indicates the order of the movement. N indicates the order of the movement, and we also told that this is called central moment of the random variable x. So this mu n is also called central moment of the random variable x. Okay, so the nth central moment, how do you find out nth central moment? Mu n is equal to expected value of x minus x bar whole power n. Now what is the formula? Integral minus infinity to plus infinity x minus x bar whole power n fx of x dx. Okay, and for discrete case, instead of integration here, we will be having summation. Instead of probability density function, we will be having probability mass function. So it is mu n is equal to summation xi minus x bar whole power n p of xi. Okay. Now if n is equal to 0, if n is equal to 0, what happens? Expected value of x minus x bar whole power 0. So this value is 1. So what it gives? It gives us the area of PDF. Its value will be equal to 1. So from this what we can say, the central moment, the zeroth central moment and zeroth moment about the horizon, zeroth moment about the horizon gives us the area of the PDF. Okay. Now for example, if n is equal to 1, if n is equal to 1, we get expected value of x minus x bar. So what is the formula? Integral minus infinity to plus infinity x minus x bar fx of x dx. Okay. So we will be writing this separately. Integral minus infinity to plus infinity x fx of x dx minus integral minus infinity to plus infinity x bar fx of x dx. So we know that what is x bar? X bar is a constant. We will be writing outside. So what is this equation gives? This equation gives us the mean value or expected value. How do we denote? We can denote it as x bar. This also gives us x bar. Okay. And since x bar is constant, we are writing x bar outside this integral. We have integral minus infinity to plus infinity fx of x dx. So what is this integral value? This gives us the area of PDF. So this integral value will be always 1. So what is the first central moment? So first central moment will be having the value 0 always. Okay. The second first central moment will be having the value 0 always. Whereas zeroth central moment will be having the value 1. Okay. Now we'll discuss the variance. Okay. Variance is called the second central moment. What is second central moment? How do we denote it as? We can denote it as sigma x square or variance of x. These are the two ways we can denote the variance. Okay. So mu2 is equal to sigma x square. It is the expected value of x minus x bar whole square. This is the formula. What is the formula for the central moment? Here is integral minus infinity to plus infinity x minus x bar square fx of x dx. Okay, so this is the formula we use here. Then for discrete case, what is the discrete case? It is summation xi minus x bar whole square p of xi. This is the equation for discrete case. Okay, and similarly, what is standard deviation? The standard deviation is the square root of variance. Okay, variance we already found. What is variance? It is the second central moment. The standard deviation is sigma x is equal to square root of expected value of x minus x bar square. Okay. Now we find out what is the variance of uniform probability density function. So for the uniform probability density function, what is the formula? Fx of x, probability density function is given as fx of x is equal to 1 by b minus a, where x value is between a and b, a less than or equal to x, less than or equal to b. And what is the formula for variance? Variance sigma x square is expected value of x minus x bar whole square. So it is integral minus infinity to plus infinity x minus x bar whole square fx of x dx. Okay. So what is x bar now? X bar is the integral minus infinity to plus infinity x fx of x dx. This is the formula we use for x bar. Okay. And in the previous case, we already found what is x bar we got a plus b by 2. So in the place of x bar, substitute a plus b by 2. So sigma x square is integral a to b x minus a plus b by 2 whole square. And what is fx of x is 1 by b minus a dx. This we have to do. Now we just expand this term a minus b whole square form. We just expand the term, okay, and apply this integration separately for each and every term. So we will be getting the result. What is the result here is a minus b whole square by 12. Okay. Skew and coefficient of skewness. So skew of a density function fx of x for a random variable x is what? The third central moment mu3. Third central moment is called skew. Mu3 is equal to expected value of x minus x bar whole cube. Okay. Now we are using the formula here integral minus infinity to plus infinity x minus x bar whole cube fx of x dx. Okay. Similarly, for discrete random variable, mu3 is equal to summation xi minus x bar whole cube p of xi. Okay. So this is the formula for finding skew. Okay. So what is the importance of skew here? Skew is nothing but the third central moment. It gives us the measure of asymmetry of fx of x about its mean. Okay. And it is the amount of deviation of symmetry from the mean value. So what is asymmetry means? Measure of asymmetry means amount of deviation of symmetry from the mean value because density function should be always symmetric. Okay. So we will be measuring how what is the degree of asymmetry of fx of x by using this q value. Okay. So if the density function is symmetric about its mean value, then what is q value will be 0. Okay. So now we'll find out what is coefficient of skewness. So the normalized third central moment or the ratio of third central moment to the cube of standard deviation. Okay, normalized third central moment, or what is that normalized central moment is called coefficient of skewness. Or how do you find out the ratio of third central moment to the cube of standard deviation is called skewness of the density function or the coefficient of skewness. Okay, how do you find out skewness? Skewness can be found by using mu3 divided by sigma x cube. Okay, so using this equation we can find out what is skewness or coefficient of skewness. So what is mu3? The third central moment. It is expected value of x minus x bar whole cube divided by what is sigma x square is nothing but the second central moment. No? So it is expected value of x minus x bar square and cube you have, that is why sigma x, no, that is why we have to take square root whole cube. So it is whole power 3 by 2. So this is called coefficient of skew or skewness.